Assalamualaikum, my name is NURUL binti MOHAMMAD JAZMI. My CAT matric number is CD200127. Today I will like to present about introduction. Numerical method is a mathematical tool designed to solve numerical method problems. It also a complete and definite set of procedure of the solution of a problem, together with computable error estimate. Eigenvalue are special set of scar value associated with the most like set of a linear equation in a metric equation. Eigenvectors are also called characteristic root. The corresponding eigenvalue, often denoted by lambda, it is the factor which the eigenvector is scaled. And it also have a many metric application in both engineering and science using eigenvalue and sometimes eigenvector. For example, control theory, vibration analysis, electrical circuit, advanced dynamics, and quantum mechanics are just a few areas of application. Next, we go to the problem statement. The problem is to determine the repeated circle motion of the static equilibrium point. To solve this problem, we can use the eigenvalue and eigenvector concept from chapter 7 to determine its eigenvalue and eigenvector. To obtain this value, we must determine the vibration and frequency. Have two objectives. The first objective is to apply the knowledge about eigenvalue and eigenvector method in a real-world problem. Second objective is to use the proper numerical method procedure and learn in assignment using mathematical software.
So next, we find some three real-world problem regarding to this project. So first is vibration, which is our choice. It is related to this project because eigenvalue are used in the mass spring damper model, one of the fundamental ideas of vibration. So it is to determine the frequency of and mode shape of a given vibration. So the second one of a real world problem, which is bridge construction. So it is the smallest magnitude eigenvalue of system that models the bridge is that natural frequency of the bridge engineer use. So in this knowledge, that engineer can guarantee that it is stable. So for the third one is in electrical engineering. So in the electrical engineering, related because of eigenvalue give information on the current flow, whereas eigenvector are the values of the boundary voltage for which boundary voltage is a scalar multiple of boundary current. So Kirchhoff matrix give the relationship between the parameters. So this can be to be considered.
Assalamualaikum and very good day. My name is MOHAMMAD ARIF and today I will be presenting the method of assessment for our group assignment. So for this chapter 7, first of all, for the question we need to draw the free body diagram for M1 and M2. After that, we need to come up with an equation of motion which depends on the m value. So if there is two m1 and m2, which means there is two equation of motion. And next step is we need to divide the equation of motion with the m value. So for the first equation, m1, and for the second equation, we divide it with m2. So moving on, after we have completed uh, doing the equation of motion where we have divided it with the m values, now we have to uh, create a general equation of motion, which is matrix m x double dot plus k x equal to 0. So after we have created the matrix, we substitute the value of k and m into the equation. After that, uh, we assume harmonic motion. So for the x value is equal to v sine omega t, and for the x double dot equal to omega square sine omega t. Uh, the reason we need to assume harmonic motion is so that the equation only have one variable, which is v, and it is the variable that we need to find. So for the next step, we rearrange the matrix to characteristic equation, which is matrix A minus lambda matrix I equal to 0. Then we substitute the value and find the value of lambda, which is lambda is the eigenvalue for the equation. So moving on, since the matrix is a 2 by 2 matrix, so in order for us to find the values of lambda, we need to use Cramer rule. Because with Cramer rule, we can develop a simultaneous equation, and we can use calculator to find the lambda values. And once we get the lambda values, we can find the value of omega, which is since the lambda is equal to omega square. Next, since we have two value of lambda, which is eigenvalue, so which means eigenvector also have two values. So for the first one, when lambda equal to 1.5659, we substitute the lambda value to the matrix, and we assume that v1 is equal to 1. Then we do the calculation, we get the value of v2. So once we get the v2 value, next we need to find the eigenvector for the second one, which is when lambda is equal to 0.6458. So as usual, v1 is equal to 1, and we do the calculation, we get v2 is equal to 0.0105. So this is the second eigenvector for the lambda when equal to 0.6458. So with this, we have two eigenvalue and two eigenvector. So that's all from me. Thank you very much.
Assalamualaikum. My name is Nilamsarii HALIM, and my metric number is CD21071, and I'm from section 9. So I will present about the validation by using MATLAB. First of all, we have to enter the metric A, which is 0.65, negative 0.4, negative 0.5333, and 1.333. After we get the metric A, we have to enter EIG equal to EIG bracket A, and we get the eigenvalue 0.4171 and 1.5659. After that, enter B equal to poly bracket A, which is we get 1.0000 and negative 1.9830 and 0.6531. After that, enter VD equal to EIG bracket A, and we will get the eigenvector, which is negative 0.8642, 0.4002, negative 0.5032, and lastly negative 0.9164. And D is the eigenvalue, which is 0.4171, 0, and then 1.5659. Next, we continue by finding the V1. By enter V1 equal to V bracket semicolon comma 1, and we will get the V1 value. And after we enter the lambda 1, we have to validate by enter v11 equal to v1 over v bracket 1 comma 1. After that, we get the v1 value is 1.000 and 0.5823. And then we have to validate the v2 by enter the v2 equal to v bracket semicolon comma 2 bracket. And we get the v2 value, and then after enter the lambda 2 by entering v21 equal to v2 over v bracket 1 comma 2, we will get the value of v2 is 1.000 and negative 2.2898. Okay, so that's for validation by using MATLAB software.
Assalamualaikum warahmatullahi wabarakatuh. My name is Shakillah ASIMAH binti MOHD and my matrix number is CD210134, and I'll be presenting about result and discussion. In our group project, we will discuss how eigenvalues and eigenmatrices might be used to tackle this issue in practical settings. Next, there are three variables according to the problem. First is internal friction, second is the mass, and the last one is the spring constant. The value is approximately measured by using an equation as k minus omega m squared equal to 0. Third, eigenmatrices and eigenvalue is a metric that provides the value for the variable in most cases in the closest and accurate number. Formation of eigenvalues Kramer rules for 2 by 2 then be used to resolve a system of two equations in two variables. The Kramer's rule for 2 by 2 can then be used to resolve a system of two equations in two variables. First, express the equation as a matrix, which is AX equal to B. The system can therefore be expressed as a matrix with A denoting the coefficient matrix, X denoting the variable matrix, and B denoting the constant matrix. And our problem-based solution for this project is by inserting the K1, K2, K3, M1 and M2 into characteristic equation as in equation below. And the value can be found by considering two equation system with variables of lambda. And next, we can find the eigenvector by normalizing V1 equal to 1. Lastly, at the end of this project, the eigenvalue and eigenvectors of the system have been found and can be used to identify the natural frequency. That's all from me. Thank you.
Next, conclusion. In conclusion, we may say the numerical method is comprehensive and defined set of a procedure for solving a problem that includes comfortable error estimate. There are some differences. For the calculation to calculate the eigenvalue, have to determine the characteristic of the vibration analysis of a two degrees of freedom system of vibration. The data collected relate uh, to a real-world problem for vibration. In this, we are finding the lambda as the omega natural frequency to find the mode shape. To achieve an approximate solution, the numerical approach can be solved in the two ways. One of the methods is to other method includes manual calculation the solution and utilizing software such as MATLAB and others. In our assignment, we achieve our objective by repeating the calculation using MATLAB software to verify the answer in manual calculation are the same.